Hey folks, we are going to look at the distributive property constant and monomial worksheet I gave you yesterday. This is the only video I'm posting today. What I need you to do is read carefully through the textbook work that I have assigned, make some notes. All of those notes support the stuff that we did yesterday in class when we were working on simplifying our like terms and simplifying products when we've got similar or the same base and our exponent rule. So again, it's sort of review and reading that stuff in the textbook, and everything should help you with the big package that I printed out and gave you. Again, the idea is that you don't have to do the entire review package that I gave you, because there are 140 pages, but realistically doing half of them at least would be pretty good, because it's good practice, and if you are getting the right answers consistently, remember that half of that package is answers, the other half is questions, so make sure you're looking at the answers and making sure you got them right. There is a chance, as always, that, because I made those with the help of some other teachers, there could be some mistakes in any of the answers, so make sure you're, not wasting too much time. If you think you're really stuck on one, just put a star beside it, and either come see me about it next week, or we'll take it up in class on Monday when we're back together. The other thing that you can do when you are looking through the textbook work is you could choose to do some extra textbook questions related to the reading that you are doing. All the reading has examples, so the idea is that you're reading through the examples and they're helping you out, and they're there to kind of serve as a guide. So if you wanted to try some questions like that are in the chapter sections, that's also a good idea. The textbook has answers to everything in the back of the book, so make sure that you are checking your answers. If you're getting the right answer, we're good, and if you're not, maybe you can figure out why, and if you can't, again, put a star beside it and we'll take it up together when we see each other. So looking at this sheet right here, it says recall from the integer section. We would follow our BEDMAS rules. We would simplify this to be 4, so we would have 5 times 4 equals 20. Then we would come over here. I'm just going to move myself out of the way here. Come over here and we would go 5 minus 8. 5 minus 8 is negative 3. 3 times negative 3 is negative 9. That's great. The other thing we could do is use the distributive property to do these same questions. And that means, and this is something we've kind of already talked about in the context of our exponent questions, but the distributive property means everything on the outside of a bracket is multiplied by anything on the outside of the bracket. So if you have the 5 beside the bracket, that means it multiplies by each thing inside the bracket. So 5 times 6 would be 30, 5 times 2 would be 10, and 30 minus 10 would be 20. Now, is that more efficient than what we did up here? No, not really, but you'll see why we're learning this way. This works here, and we have 15 minus 18 to give us negative 9. Sorry, what did I do wrong there? 3 times 3 times 5 is 15. Oh, sorry, 3 times 8 is not 18. It is 24. Let's fix that right now. 24, and we are at negative 9. That's better. Okay, so distributive property means everything in the one bracket times everything in the other bracket, one at a time. So some of this is review of what we've already done, and some of it is just an expansion of other concepts. And I know some of you already learned this because you've been talking about it for the last couple days. This 3 needs to multiply by each term in the brackets. There is one term in the brackets, it's negative 2x. Remember that a term is separated by a plus sign or a minus sign. So if you don't see anything separating things, and there's no plus or minus between this 2x, we're simply going to go 3 times negative 2x is negative 6x. 4 times negative 3 is negative 12. and F is F squared. Remember that this is all one term as well. This is what we practiced today or yesterday when you're watching this video. And this means that we could put brackets around each individual piece of this term, but remember that this is all a product. So 4 could be moved around, so you could rearrange it to be 4 times -3 and F times F. Not sure why I want to make the F's 5s. Anyways, so this is not new. The same deal here. This is one product. So one term, you could rearrange it with the numbers, the numerical coefficients out front, and we put our Q's after that. So Q2 times Q3. We're able to go 2 times 4 is 8, and Q2 and 3 together makes Q5. Remember that that's because we're expanding this out, and it would be Q, 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 Q. So 5 Q's multiplied by each other could also be written as Q5. Now, the distributive property comes in handy when we look at this one right here. So this means everything on the outside hits each term on the inside. And these are separate terms. They're separated by a plus sign. 4 times 3x, 12x. 4 times 7, 28. Same deal here. -10w and -15. Same deal here. We've got -3 times -4c giving us +12c, and -3 times +2 giving us -6. So our distributive property is that coefficient on the outside of the brackets multiplying by each term inside the brackets. First, we check to see if we can simplify anything in the brackets. We can't, so we move on. Nothing changes when we've got more than one. We hit it 1, 2, 3, 4 terms hit by that -2. So -2a cubed plus 8a squared minus 30a plus 60. If you look through this, there are no like terms because we've got a cubed, a squared, a, and 60. So these are all different terms. We cannot simplify it any further. Same deal here, 6x squared minus 9x plus 21. Again, we cannot simplify that further, so we're good. These are done the exact same way. We've got a fraction. Now, a fraction can be multiplied by each term. And it just so happens that we can do a quarter fairly easily. However you choose to do this is up to you. You want to use your calculator, you want to write this out longhand, but a quarter of 8 is 2. So hopefully we can do that in our head. 1 times 8 is 8. 8 divided by 4 is 2. So 2x squared y is our first term. And then a quarter times 20. And again, 20 divided by 4 is 5. And a quarter of 20. 1/4 of 20 is 5. So no surprises there. We're able to do this. Two separate situations here. Now we've got two ways of looking at this. One way is you could leave this negative by itself and treat it as a minus sign and just deal with distributing the 3. I personally think that it's easier to group them together and distribute the negative on each term in one step. So this is why I put the brackets around it right there. So 2 times 3wx gives us 6wx. 2 times -4yz is -8yz. Then I move here and I'm -12wx. And I've got -9yz. So we're not done with this one. We're in a situation where we can simplify further. When we're grouping like terms, remember we're playing a matching game, and what we've got to do is we've got to look for the exact same base and exponent. So wx is found here and wx is found there. So we can go 6wx minus 12wx gives us -6wx. And right here, yz and yz, that's cool as well. -8, -9, we can put those together to make negative 17yz. Remember, negative 8 degrees, we go down to negative 9, go down 9 degrees from there, we end up at negative 17. So you can see our integer skills being practiced when we're simplifying here as well. Okay, we keep rolling. A couple more examples. The next one will be done exactly the same. This is a fraction, so it's a little bit uglier, but that's okay. 2 times 4, we'd have 8 over 3 RS. 2/3 times 7, we'd have 14 over 3 RT. That's just what it is. No problem there. Just a little bit uglier because we've got to go 2/3 times 4. Remember that when we're multiplying fractions, we just multiply straight across. So it's like 2/3 times 4 over 1. 2 times 4 gives us that 8. 3 times 1 gives us that 3, and we're done. This one would be the exact same as well. Multiplying each term. Multiplying each term. So negative 8b4d minus 4ac to the power 7 minus 15b4d negative 9ac7. So when we're grouping like terms, we've got a line and a line and a squiggle and a squiggle. So I'm organizing these. You could use colors, you could use a shape, you could use circles, you could do it in your head, totally up to you, but I think it's a good thing to do something to organize your like terms. These are like terms because you've got a B4D and a B4D. So they match up perfectly. Negative 8 minus 15, we end up with negative 23b to the power 4d. Negative 4 minus 9, negative 13ac7. So this is how we use the distributive property. Just keep rolling because why not? There's lots of examples to do here. This one right here, this negative 7s is just a term that sits out by itself. It's this part right here that we can distribute through here. Now, sometimes we get a little bit hung up on where that minus sign goes. I mentioned it before. Think of it this way. This minus sign separates this entire term, so it applies to each thing. So like one way or another, you've got to distribute that minus sign through things as well. And it's easiest to do it in the first step, making that negative 3s squared minus 9. Same deal here. We've got a negative 2 on the end, negative 3s minus 9. Minus 2, that negative 2 is just out there by itself. We can take this a step further. And we should also make sure we're not rushing and writing down the wrong numbers. That 3 times 2 is definitely 6, not 3. 3 times 3 is still 9. So we end up with negative 6s minus 11 because this negative 9 and negative 2 combines to be negative 11. Okay, so a couple more. Let's see. You're getting the idea, I think. I'm going to skip over to one. Well, here we've got some where we've got a letter, right? We've got that literal coefficient situation where we're applying our exponent rules to an x or a c. So this x distributes just like a number would. X times 5x, 5x squared. X times 4, 4x. We do it here. C squared times 3c, 3c cubed. C squared times negative 4, negative 4c squared. Keep rolling. Negative 3d cubed, because we've got d and d times d. That would be like d times d times d. How many are there? There's 3. d to the exponent 3. The negative 3 doesn't change. And we also have to make sure that we go negative 3d times 3, which is negative 9d. You cannot combine these because they are not like terms. D to the exponent 3 is not the same as d. Okay, keep going. 6d to the exponent 5 plus 12d to the exponent 4 minus 8d to the exponent 3, and 2 times 5 is 10d to the exponent 2. So lots of distribution happening here. Now this one right here, we actually have one product. So we've got a negative 8g squared h, and we've got a times a negative 7g cubed h squared. So this is all one big multiplication question. If you know what u at g and h were, you would sub numbers in for them, and you would have a number times a number times a number times a number times a number, and you would end up with probably a big number. But we don't know what those are, so what we can do is try and simplify them. So going back to yesterday, I suggested a nice strategy is to deal with the numbers first. Negative 8 times negative 7 will give you 56. And then see what we can do with our unknown bases and powers and using our power rules here. So g squared times g to the exponent 3. Same base, multiplying, add the powers. 5, same base, multiplying, add the powers, h to the exponent 3. We've accounted for everything here. Again, we do it here. Let's take care of these coefficients on the outside. 4 times negative 2, negative 8, x times x to the power 3, x to the power 4, y times y squared, y to the power of 5. So again, one big product simplified. Still a product, right? Like it's still one product. All we've done is make this a little bit more efficient, because remember, we could write this out and it could be 4 times negative 2 times x times x times x times x, and then there's times y times y times y times y times y. How many y's? There's 5. How many x's? There's 4. 4 times negative 2 is negative 8. So try to use all your rules together, and this stuff will start coming together reasonably quickly. Last couple of examples. We hit the k inside here. We get 3k. I like to write the numerical coefficient on the outside, left side, just because it's better formatting for us. We talk about 3k, not k3. It makes it a little bit easier when we think about k representing something. So it could be like, if k represents kittens, that's 3 kittens, not kittens 3. If k represents 3 or 5 or any number, then it's 3 times 5 or 3 times whatever that number is. K times negative k is going to give us negative k squared. Negative 2 times 2k squared, negative 4k squared. And negative 2 times k is going to give us negative 2k. Now we have a quick look here, and we are in a situation where we can combine some like terms. Those are like terms, as are these. Remember that k's are different than k squared, so when we put our k squareds together, we get negative 5k squared. So negative 1 and negative 4 makes negative 5. 3k minus 2k is k. Positive k. 3 minus 2, positive k, or 1k. You cannot combine these together because, again, k is not common with k squared. One more example, boom, boom. This is something I really want to pay attention to. Remember how we talked about this minus sign can be treated as a negative 1, and that negative 1 distributes through anything. This is why we had a little bit of trouble when we were thinking about whether or not our exponent would be something that whether or not the exponent applies to what's in the brackets or out of the brackets. This minus sign is like a -1, and it distributes through this set of brackets. So each term in there gets hit with a -1 or a minus sign, or some people honestly start going, oh yeah, I'm subtracting everything in that bracket, so every sign in that bracket will change because it's affected by the negative. So -2m times m squared is -2m to the exponent 3. -2m times -3m is positive 6m squared. -2m squared and a -8. -2m cubed, we can combine our two like terms, 4m cubed minus 8. Okay, I'm aware that that was fast, but I didn't want the video to be too long. And the good news is you can rewatch it and you can look through how the questions were done. And I'm hoping that this helps you out. And I'm going to post this note on our classroom right now. Anyways, good luck with the content tomorrow. And like I said, please feel free to send me a message or drop by next week during study hall, like Wednesday, Thursday, Friday. If you are planning to come, if you can do me a solid and maybe email me ahead of time, just so we are sure to connect. And I make sure we just don't have too many people in there because I don't want, I shouldn't mix up. You shouldn't have too many of you in there with the other class. I don't think that's going to be a problem, but just give me a heads up before you show up if you don't mind. And again, do your best on this. Send me some messages if you have questions. I will be looking at my phone even tomorrow while I'm at my appointment, so I might be able to give you some feedback there. But Mr. Smith is a pretty solid guy, and he can probably help you with some of this. All right, folks, thanks for watching, and good luck with your homework today.